Hello everyone, greetings to Dr. Nohafiza binti Saleh. We are from Group 6. We will present our static and dynamic group project. First of all, let me introduce the members of Group 6, including myself, Seraphim Moy Chao En, Jovita Tan Royal, Lim Mi Tian, Doris Kong Chen Jin, and Wong Dong Hang.
My name is Jovita Tan and my matrix number is AF210088. The structure that I choose is a short span bridge which is located at the bicycle lane of Kapasing Drive, Penang. A bridge is a spanning structure that spans a gap between 2 points such as a river, canyon, valley, road or railway. Bridges are an important part of civil engineering and a common aspect of the built environment. The basic principle of bridge design depends on the nature of spanning structure, shape, material, means of support, distance spanned, terrain, function, budget, exposure, and so on. So the function of this bridge is to connect 2 points across the river, and the material of the bridge is I-beam, concrete for deck, and steel for handrail. Next, this is the idealization of the bridge. And this is the free body diagram. Next, cell weight of the bridge is calculated. Then assume the mass of load is 2 kN per meter. And then the support reaction is calculated. This figure shows the idealization of the structure with x and y axis. Then the centroid of the structure is calculated. Mass is used for the calculation due to the different density of material of the structure. So the centroid of the structure is 12.4988 meter from x-axis and 0.3642 meter from y-axis. This is a calculation for moment of inertia of the structure. In conclusion, safety of the structure is very important. The handrail has extended 1 meter due to the safety issue, and according to the calculation, it won't affect its stability. The support reaction, centroid, and the moment of inertia have been calculated, and the values are logical and reasonable according to the estimation. Based on the calculation, we can conclude that the structure is strong and stable.
My name is Seraphim Moy Chao En with matrix number AF210118. The structure that I have chosen is roof. Roof is a structure forming the upper covering of a building or other shelter. The structure is a series of trusses, beams, and rafters that give the roof its shape and that the roof sheathing is laid upon. The structure in the slide is a hut located at Taman Pelangi Indas Playground, Johor, and the materials used to build the roof are concrete or clay tile. This is the free body diagram that I have sketched with 2 types of support. The first support is pin support with reaction AX and AY, and roller support with reaction DY. The estimation of load is 600 Newton at 5 different parts of the roof. For the support reaction with moment at point A equal to 0, we get reaction DY equal to 1500 Newton. Next, as total Fx equal to 0, we get reaction Ax equal to 0, and lastly, by calculating total Fy equal to 0, we get reaction Ay equal to 1500 Newton. For the centroid, I've divided the roof into 2 sections. From the calculation, the centroid of the structure is 4 meter from x-axis and 2.667 meter from y-axis. From the calculation, moment of inertia for x-axis is 113.778 meter power 4, and for y-axis is 85.304 meter power 4. As a conclusion, the support reaction, centroid, and moment of inertia have been calculated, and the values are logical and reasonable according to estimation. Based on the calculation, we can conclude that the structure of truss invent allows the weight of a roof to be distributed to the outer walls or columns for better support. Roof truss maintains your roof's overall structural integrity by providing support for its inclined, vertical, and horizontal loads. Trusses combine horizontal beams and diagonal beams to form triangles. Triangles are usually used to make trusses because it can bear weight very well. Triangles are very strong shapes, which makes them important when building strong and stable structures. That's all from me, thank you.
Hi everyone, my name is Ethan, normal metric AF210110, and now I will continue the beam structure for our group assignment. So as you can see, this is the example of beam structure located in my house, Kepong, Kuala Lumpur. So as an introduction, beam is a type of architecture used in engineering construction to offer a secure and convenient load road that distribute weight effectively throughout a building base. The load distribution of the beam is put beneath the foundation and column to supply more extensive structural support. So for a fixed beam is one that has support from both ends of the beam and is rigidly fixed with support, incapable of producing bending moment and has no vertical or rotational motion. So this is the free body diagram shown. So we can see the reaction AX equal to reaction BX and is equal to 0. So this is the estimation of load. So we assume the mass of load is 50 kN per meter and the length of beam is 3 meter. So the magnitude is equal to mass of load times the length of beam is equal to 150 kN. So our problem is become simply for the beam, with the point load is 150 kN at the middle. So this is the support reaction. So we can see the Fy is equal to Ray plus Rby, which is 150 kN. So the By is half of the Fy, which is 75 kN, and Ay is equal to By, 75 kN also. So this is the central or central rod of the beam. So we can see that we have divided into one area. So the area with length 3 meter and the width 0.2 meter. So we got the area is 0.6 meters square. So we can get the X 1.5 meter and Y is 0.1 meter, with AX and AY 0.9 and 0.06 meter cube. So this is the moment inertia for the x-axis. So we can see the Ixx is equal to Ix plus ADY squared, which is equal to 0.566 meter to the power of 4. So for the moment of inertia for y-axis, which is also equal to Iy plus ADX squared, which is equal to 1.4211 meter to the power of 4. So in a conclusion, a beam is strong and stable enough for housing structure. So this we can consider the structure is safe. Next is familiar design, which widely used in many building structure because it was easy to build. Next, the beam is important to consider all these factors, which are material use, size, strength, durability, and the structure design. So last but not least, it is significantly important to the effect of the safety and durability of the structure built for a long run. That's all from me. Thank you.
I'm Doris. I would like to present cantilever slab. Cantilever slab is only supported at one end and the other end carrying a load. Longer cantilevers are consolidated in a structure when clear space is needed beneath. Cantilever slab can be made out of steel or concrete. This is sample solution to find support reaction. First of all, a free body diagram is sketched. Then we use equilibrium formula, which means sum of Fs equal to 0 and sum of Fy equal to 0 to find the magnitude of Ras and Ray. Then, moment at point A is calculated by using force times perpendicular distance with A. This is solution to find center of centroid. First of all, the structure are divided into two sections. Then, area S, Y, area times S, area times Y are calculated respectively for section 1 and section 2. Then, central for S is calculated by using sum A times S divided by sum of A. And then, the central for Y is calculated by using sum of A times Y divided by sum of A. This is simple solution to find moment of inertia axis X and axis Y. For both axes, area is copied from the previous slide. Then, for axis S, Is is calculated by using rectangular formula, which is V times H cubed divided by 12. Then, change in Y, dy is calculated by using center of Y minus Y. Then, A times dy squared is calculated. Finally, Ixx, which is circle moment of inertia, is calculated by using Is plus ABY squared for the section 1 plus IS plus ABY squared for section 2. For axis Y, IY is calculated by using B cubed times H divided by 12. Then H in S, delta S is calculated using center of S minus S. Then A times delta S squared is calculated. Finally, circle moment of inertia for axis Y. IYY is calculated by using IY plus A delta S squared for section 1 plus IY plus A delta S squared for section 2. In conclusion, statics is very important to be studied before a building construction. This is because statics introduce different types of cantilever slab and support reaction on cantilever slab. After that, designers have to ensure the structure of building can withstand the force acting on it to produce a safe building. That's all for me. Thank you.
Hi, my name is Wang Donghang, matrix number F210112. Today, my presentation will focus on beam and column structure. Let me introduce what is beam and column structure. Column is a vertical element and used as support, whereas lintel is the horizontal beam supported by column. The beams between the supports are typically in the same horizontal plane and forming a single straight line. Beam is a horizontal structural component that mainly carries vertical loads, and column is a vertical structural element that is attached to a roof slab, beam, or ceiling withstand against the bending. Columns and beams are important since the ancient world and has been adapted from the first basic beams and columns. Figure below shows the actual beams and column and idealization of the structure at Examination Hall F2, University Tun Hussein On, Malaysia by Raja Johor. So let's proceed to the side view. So this is the free body diagram of the structure. This is the calculation for the estimation of load. 3.5.4 shows the calculation of the support reaction. The reaction of AY and BY are the same with the amount of 1765.8 Newton. This illustrates the diagram how we calculate the center of centroid. Next. This is the calculation of the centroid of the structure. So we got X is 5 and Y is 2.295. The moment of inertia of the structure about X-axis is 28.6253 meter power 4, and about the Y-axis is 6,899.7617 meter power 4. And as a conclusion, further analysis show that the calculation for the body diagram, support reaction, centroid, and moment of the inertia has been identified that the structure of beam and column of the building is logical and also has stable structure which can last long for many years. This evidence in the case of we have to use a suitable method and reasonable structure, because these are the major factors which will affect the stability of the structure. Application of static and dynamic plays a vital role in civil engineering, so that we are able to calculate and judge the safeness of the structure in a construction. That's all for my presentation. Thank you.